All right, guys. So like we were saying earlier, a geometric series is a sum of a geometric sequence. So a series is when you add them all together, add all the terms together. And we have a formula for this. To find the sum of an nth term, you would take your first term, AF, your first term, and you would multiply that by 1 minus the rate to the nth power, and you'll divide this whole thing by 1 minus the rate. So the best way I think to illustrate this is an example. Let's look at example 3. It says evaluate, which just means solve the following series. So we're thinking sum using the summation formula. And so we have our terms here. We have A1 and all the way to the end. It tells us that's our 9th term. And we want to figure out what our first term is, which is 1.4. And we need to know what our rate is. And we know that n equals 9. So to find the rate, we want to just take any term and divide it by the term that precedes it. 2.8 divided by 1.4 is 2. So that's our rate times 2. And if you wanted to keep checking that with 5.6 and 2.8, you would get the same answer. So now we've got all our numbers. We just need to plug them into our summation formula and solve. So we're looking for the sum of the 9 terms. And we know that our first term is 1.4. And that's going to be 1 minus the rate, which is 2, to the nth power, which in this case is 9, over 1 minus 2. So 2 to the 9th power, 2 to the 9th power is 512. 1 minus 512 equals negative 511. 1 minus 2 is negative 1. Sorry, I don't know why my pen switched to the eraser. Okay, now I've got to multiply 1.4 times negative 511, and that gives me negative 715.4. That is over negative 1. A negative divided by a negative equals a positive, and any number divided by 1 is just itself. So the sum of our first 9 terms is 715.4. And we would say that this is a divergent sequence because the numbers are getting higher and higher and higher. We would guess towards infinity.